In this video, we are going to cover complex numbers or the imaginary number. Make sure you watch all the way to the end because I am also going to cover the interpretation of these complex number in terms of how it looks like in a graph or in visualization. So let's start with a complex number. How we define the complex number, denoted by I, and it is nothing but the square root of -1. So a complex number denoted by I is nothing but a square root of -1. We'll come to it how we can visualize it. So if I is equal to minus of square root 1, then I squared is going to be -1 square of square root of -1. So this is going to be -1. Just keep in mind and memorize it. Now if I want to find the value of I cube, it's going to be I squared multiplied by I, and I squared is -1. So this is going to be minus I. Moving forward, what is going to be I to the power 4? It's nothing but I squared, and I squared is -1. So -1 whole squared is nothing but 1. So raise it to the power of 4 and I becomes same, I bar 4 becomes 1. Let's take a look at some more complicated scenarios. What is 1 upon I? 1 upon I can write at I square divided by I. So I squared is I squared divided, actually I divided by I squared, because we multiply both the top and bottom by I. So this becomes I squared is -1. So this I by -1. So this is minus I. Let's say 1 upon I to the power 3. We can do it using this way. I can multiply top and bottom, numerator and denominator, by I. I get I divided by I to the power 4. So this, and I to the power 4 is 1. So this is going to be I. These are some of the basic notations. And let's say move on to something more complex. Let's say what's value of I to the power of 3n plus 2, or maybe let's make it a little simpler, I to the power 4n plus 2, where n is in integer. So I can write it as I to the power of 4n multiplied by I squared. In I to the power 4 is 1. So 1 raised to the power n is always going to be 1. And now I squared is going to be -1. So this is always going to be -1 no matter what the value of n is. There could be more complex. In SAT exam or other such exams, there are some types of questions that you come across, and then we are going to look at those problems. The imaginary numbers typically are a general imaginary number will be written as in the form of x plus iy, and you may be asked to write in expression in this format. For example, let's say we are given 3 plus 2i multiplied by 5 plus 2i. What is the answer? So this, what you do is you just multiply the way you do. 3 plus 5 is 15, and then 3 plus 2i is 6i, and then 2i into 5 is 10i, and then this 2i multiplied by 2i is 4i squared, and 4i squared is I squared is -1. So this becomes -4, and this gets added to this one. 15 minus 4 is 11, and these two guys add up becomes 16i. With this we can express in the form of x plus iy. Let's take a quick another example, maybe simpler one. 1 plus 2i multiplied by 2 minus I. This I will write it quickly. we know that this multiplied by this is 2, and this time I'm going to multiply this with this, so minus 2i squared. So it's going to be minus 2 into minus 1 because I squared is minus 1. So we have plus 2. So this and this multiply to give you plus 2. And then 2i multiplied by 2i is 4i. And then 1 multiplied by minus I is minus I. So this answer is 4 plus 3i. There are few special scenarios that need to be aware of. That becomes the basis of the next problem we will be doing. When, for example, 3 plus 2i multiplied by 3 minus 2i, in such scenario, it converts in the form of a plus b multiplied by a minus b. So it becomes, you can apply the formula a squared minus b squared. It's 3 squared, which is 9, minus 2i whole squared, which is 9, minus 4i squared. I squared is minus 1, so this becomes 9 multiplied minus plus 4, that is 13. So in such special scenarios, this simplifies to just a single real number. This number like this has two parts generally. This is the real part and this is the imaginary part. Let's take off another class of problem that you will be coming across. It is typically you convert a number, let's say 3 plus 2i divided by 4 minus 3i. In such a scenario, we will use the last problem we did just now. What we will do is we will multiply this denominator. If it is a minus bi, we'll multiply it with a plus bi. The idea is this whole thing, when multiplied by its complex conjugate, the complex conjugate is, if a number is 4 minus 3i, its complex conjugate is 4 plus 3i. So let's multiply this 4 minus 3i with 4 plus 3i. And then I do the same thing in the top, 3 plus 2i multiplied by 4 plus 3i. In the numerator, I multiply 3 into 4 is 12. Then 2i multiplied by 3i is 6i squared. That becomes minus 6. And then 3 into 3i is 9i. And 2i multiplied by 4 is 8i. And this is divided by 16 squared. And minus, this is 4 squared, which is 16, and minus 9i squared becomes plus I, because I squared is minus 1. Here we get 6, and 9 plus 8i is 17i, and this becomes 16 plus 9 or 25. It is generally written as 6 divided by 25 plus 17 by 25 times of I. So you need to practice some of the problems like this. Let's do one more problem of the similar thing. Maybe take anything, not something complicated. 2 plus 7i divided by maybe 6 plus 5i, anything you can say. So I multiply this whole thing by 6 minus 5i. So 2 plus 7i multiplied by 6 minus 5i divided by 6. I write it directly. So it is 6 squared 36 minus 5i squared, 5i whole square, that is 25i is whole square. And then you start making the habit of eliminating some of the intermediate step to get the faster result. So 2 into 6 is 12 minus 35i squared, which is plus 35. 12 plus 35 is 47. And then 7i into 6 is 42i minus 10i is 32i, and this divided by 36 plus 25 is 40 61, if I am correct. So check my answer if I have done or not, but I have tried to eliminate some of these steps. If you keep doing like this, you should be able to do most of the problems like this. Some of the things you need to know more about is the something called complex conjugate. Complex conjugate of a complex number z is equal to a plus bi is denoted by maybe something like this: complex conjugate a minus bi. This is the complex conjugate of this number. In the same way, we say define modulus of a number, modulus of a complex number denoted by mod z as equal to square root of a square plus b square. A couple of more things you need to be aware of, and now here comes an important thing. What I would like you to do is how the whole thing relates to a visualization, and for this I'll go back and to plotting a function. Let's say y equal to fx equal to, let's say, x squared plus 7x plus 6, and we know that this is a parabola that we can plot. And I also encourage you to use Desmos to plot this. This is y-axis and this is x-axis, and I'm going to plot. So how do we plot it? We know that as x increases, y increases faster because of this square term. I can factorize this. I will get x plus 3 multiplied by x plus 2. So it has two roots, one at -2 and another at -3, something like there. So it's going to look like a parabola, something like this. And it, when x is equal to 0, when x is equal to 0, y is equal to 0 plus 0 plus 6 is 6, which means that at x equal to 0, this number is 6. So this is the parabola and these are its solutions. Now what I'm going to do is I'm going to lift this whole parabola up, moving it upwards. And how one way to move the parabola upwards is by increasing this number 6 here. For example, I can write fx equal to x squared plus 7x, maybe 10, or something, or I can rate it 20, etc. I can keep on increasing it. The parabola starts lifting it up, lifting this whole thing upward. There comes a point, the 2 points that it intersected, it goes above it. And how do we know that? We know that to solve this equation is x equal to minus b plus minus square root of 7 squared is 49 minus 4ab is 4 into 6 divided by 2a. So 49 minus 24 is 25. So b square minus 4ac is 25 here. When I increase this number 6 to, let's say, 10, what happens? This solution becomes minus 7 plus minus square root of 49 minus, or even let's say 20. When I am 20, it is 4 into 20. This thing becomes negative. When this is negative, the parabola will look something like this. At that point of time, it does not cut anywhere on the x-axis, and at that particular point we have an imaginary solution, because this square root, for example, this one has a solution of minus 7 plus minus square root of 80 minus 49 is minus 31. Okay, divided by 2, or we can write it as minus 7 plus minus 31i divided by 2, and that gives me the origin of a complex number. So this is how you can visualize this. In one way is the larger this imaginary number, the farther this parabola is away from the axis, so as to say. But